Thank you. Thank you, Kerry, for this opportunity to talk. So I thought this, in a way that Nalini did, I will give you a little bit of how I have landed up in data science. Most of my work is, before I start, let me acknowledge the people of the Woiwurrung and Boonwurrung language groups on the Eastern Kulin Nations, which is the land on which I'm residing. So, my work comes from cybersecurity. So why is securing of data so difficult? It's because we are generating more and more of data. So if, you may have heard the word petabyte being bandied around. So suppose, to get an idea of what a petabyte is, if we took 10 petabytes and we stacked the hard drives which contained these 10 petabytes, we would land up with a tower which is taller than the Burj Khalifa, which is 828 meters. The Burj Khalifa is the tallest building on Earth at this point. So, and we are trying to secure that data. And how did I get into this thing? So back in 1999, 2000, we started a Master of Cybersecurity at RMIT. So that got me into thinking about cybersecurity. And then in 2006, I had to build up expertise in risk management, and teach it to these students. So that's when I started looking at cybersecurity, not so much from the mathematical perspective. My research before that was very much to do with communications and coding and cryptography, for sure. But now I started looking at it from the point of risk management and the point of view of cybercrime. So what you have here, a picture, is when I was able to attend the 4th Intergovernmental meeting on cybercrime in April 2018. So the governments across the world are trying to deal with cybercrime. So one of the things I looked at between when I started, which is about 2006, looking at risk management, and before I got to this, and how did I get to that, is I looked at basically money laundering. And in about 1996, the Anti-Money Laundering Counter-Terrorism Financing Act was introduced. And it left out small and medium enterprises. And part of doing, working in the cybersecurity, teaching it to the Master of Cybersecurity, I had students who were interested in looking at this for their, basically their master's minor project. So we looked at money laundering and looked at how could we bring, from a money laundering point of view, how could we bring small and medium enterprises into the fold, or rather what tweaks were necessary. And that work that I did and it was published in the Journal of Money Laundering Control, got me to Vienna. I got invites basically from 2013 onwards to the intergovernmental meetings. So when I was doing that, of course, prospective PhD students looked at what I was doing and they wanted to work in complex networks, or rather in money laundering. So how do we do that? So let me give you a little bit about what money laundering is. Money laundering is where you take money on which tax has not been paid and pretend in some way, shape or form, that money you've actually paid tax on it. The way that was, and this money laundering and counterterrorism financing cost the world billions of dollars every year. And so both money laundering and counterterrorism or terrorism financing, the 9/11, for example, cost US dollars 500,000 to take, to organize. So where did the term come from? It actually came from coin-operated laundromats. Because if they were coin-operated, you couldn't tell how much of laundry had been laundered, how much clothes had been laundered. But it doesn't work. I've said does work anymore, no, doesn't work anymore, because now we have water meters. We check how much of water you have used, and that's a good way of showing that there is this much of water, and you can't have laundered so many more clothes. So that's how the term money laundering comes in. So what about money laundering? So when a PhD student wanted to do work in this, we looked at it, and the problem is tracking of money laundering is very difficult, because unlike fraud, money laundering does not directly affect the company. And you will have seen that, HSBC has been brought up for money laundering, the largest before Commonwealth Bank, which was fined, I think, $1 billion. There was Westpac, which was fined about, $800 or $700 million for allowing money laundering to happen. As you can see, it doesn't directly affect, so it's hard to track. For example, the Swiss subsidiary of HSBC Bank did not get prosecuted properly. And the result ultimately was that the chairman was there at that time, became a UK government minister. So clearly there is not enough penalties being imposed. And the problem is basically that it is very, very hard and very expensive to actually find and prevent it. So, and there's a very interesting fact here that in Mauritius, apparently, there are more government officials working on stopping money laundering than there are listed officials. So is there a better way? So that is what my PhD student look at. The question is, getting real data for this sort of research is very, very hard. And the Enron, so what she used was the Enron data. So what is the Enron data? These are the email communications that were that basically all email communications that went inside Enron before and after the collapse of Enron in 2001. And this was basically dumped on the internet. It's still available. And why was this an interesting data set for money laundering? It's because 10 people from Enron were subsequently convicted of money laundering. So there is some ground truth for our work. So the joint work that I did with that PhD student, who was a computer science student, not really a mathematician, we found a better way, a sparser network to identify. And what we did when it says only this network that she came up with had 30 nodes and all 7 criminals who had been convicted. And so if we compare this with, so for example, the K neighborhood detection, the one neighborhood of Andrew Fastow, who was considered the mastermind here, had 26 nodes and 149 agents and only one criminal other than himself. While the second neighborhood of Andrew Fastow had, many more nodes, making it really hard. So this was a different way of finding. So, and I call this graph mining. And what this uses basically complex networks, which to me is graph theory on steroids. That's how I look at complex networks, graph theory on steroids. So where did I go from there? So I had other PhD students who did a range of work. The more mathematical students, so students who had a Bachelor of Mathematics did more mathematical work, for example, using the clustering coefficient, using statistics to predict the popularity of an item. For example, here you have the heat map, which shows there are the ratings given by viewers of movies and the average rating. So we came up with what we called a popularity score. And that basically, so the ones which are right up here are the ones which are most popular. Okay, we also did comparing of election wins to social media campaigning. So what was done before is that the election wins are usually, they would only compare how many likes, for example, on Facebook, how many tweets, how many retweets. So we came up with a better way of looking at the validity of using social media for campaigning. So this was back in the 2013 and 2016 elections. So we also were able to visualize crime data. So there's a whole bunch of things that is possible from this. And basically I will stop there. I don't know if I have any more time, but let me be quick and stop.